This problem we discuss velocity and acceleration diagram for toggle mechanism, which is having angular speed of 180 RPM and angular acceleration is 50 radians per second square. So we have this arrangement of toggle mechanism. The lengths of links are given. OA is given 180 mm, that is input link at an angle of 45 degrees. Then we have AB link 360 mm. Then BC and CD dimensions are available. BC value is around 240 mm and BD is given 540 mm. Okay. Now the question is you have to determine velocity of slider D, angular velocity of BD, acceleration of slider D, and angular acceleration of BD. Now to solve this problem, first we have to create the actual composition diagram with given data. So first we'll mark this point O. Okay. Then for locating point O, we locate this point B and C. Okay, so OA is available. That OA value is 180 mm. You can take scale 1 centimeter is equal to 60. So this line will drop around 3 centimeter at an angle of 45 degrees. Then we have next part AB. AB distance is 360 mm. Okay, so we can take 6 centimeter distance in compass and we can mark R. Then CB distance is also available. This CB is 240 mm. Again, we can take 4 centimeter distance in compass again draw second R. Now orientation of O and C is available. Vertical is 360, horizontally 105. Okay. So based on scale 161 as 260, we can take this part 6 centimeter and this is around 1.8 centimeters. Okay. Now next, we can locate by intersecting AB and CB. We have this point B. So we can connect AB line and CB line. Next, BD distance is available. So just draw horizontal line, take BD 540 mm, that is 9 centimeter in compass, and mark the distance on horizontal line, we get point D. So connect B and D. So this is the overall arrangement of configuration diagram. Now what data we have? The crank speed is 180 RPM, so its omega value will be 2 pi upon 60. That is 18.85 radian per second. So velocity of crank will be R into omega. V into omega, 18.85 into length of crank 0.18, that is 3.4 meter per second. Okay. Tangential acceleration is also available 50 radians per second square. So you can also calculate tangential acceleration of crank OA, which is R into alpha, 50 into 0.18, 9 meter per second square. So what we have, velocity of OA and acceleration of tangential acceleration of OA, that we can calculate. Next, to plot that velocity diagram, we'll prepare this table, which will define the length of link, angular velocity, linear velocity, and its orientation. So velocity is tangential to motion. So first we have this crank speed. Omega is 18.85 radian per second. Length of crank 180 mm. This is 0.18 meter. So velocity of OA will be R into omega. 18.85 into 0.18. So this will be 3.4 meter per second. Similarly, by taking appropriate scale, we can draw that velocity component of OA. Now this OA rotates in clockwise direction. Okay. Just to check the orientation of that particular diagram. It will be rotating in clockwise or anti-clockwise. That we will check. Okay. Just I will show you that part. It is given anti-clockwise direction. Okay. So this part of OA, when we are plotting the component with A, it will be in upward direction. Okay. So this part will be this component, tangential component will be in upward direction. OA will be of 3.4 centimeter. Scale is 1 centimeter is equal to 1 meter per second. So this line will be of 3.4 meter per second. This is 0.8. Then next we have to draw second part, second tangential component for B. So just draw one line that is perpendicular to AB. You can draw one more line perpendicular to CB. So intersection of AB and CB will define the orientation of B. Connect B and A, connect C and B. So this will be the orientation of point B. Then we have one more point, that is D point. That is the slider orientation. So slider is sliding in horizontal direction. So just we'll draw one horizontal line and one vertical line for point for link BD, that is tangential line. So this parallel and vertical line will intersect at one point, and that is the point of slider, position of slider D. So you can connect D and B and D and C. So you can measure this velocity of slider D. So this distance is around 2.1 centimeter. It is 2.1 meter per second. And we have angular acceleration. So angular velocity of BD we need to measure. So it is angular velocity. V is equal to R omega. So VBD is available 2.4 meter per second upon actual BD length 0.54 meter. So by putting that velocity upon actual dimensions, we'll get angular velocity of link BD, that is 4.44 radian per second. So this is all about calculations of velocity of slider D and angular velocity of link BD. Then next we'll discuss acceleration diagram. Okay. Now in case of acceleration diagram, again we have normal and tangential component. In our case, we have tangential component of acceleration because angular acceleration of crank is available. So we'll plot normal and tangential component for crank OA. Now before plotting that normal and tangentials, we just draw that calculate that normal component value r omega square, which is 64.2 meter per second square. Tangential component of acceleration r into alpha, that is 9 meter per second square. Then normal component of link AB r into r omega square is 2.25 meter per second square. For CB it is 31.5 meter per second square, and for BD r into omega square is 10.67 meter per second square. Now for all these cases, first we look at O dash and C dash, that is fixed point. Then normal component is parallel to link, tangential component is perpendicular to link. Okay. Now this is in upward direction. Why? Because it rotates in anti-clockwise direction. That's why this tangential component is in upward direction. So after plotting normal and tangential component of accelerations, we have this resultant of O dash and A dash. So this will be your resultant component of acceleration for crank OA. Okay. The next for point B, again B is in downward direction, we'll plot B in upward direction. So this will be y dash line AB, which is 2.25. So scale is 1:10. That means this is of only 2 mm. Okay. Then again we have to draw one perpendicular component, that is for AB. Okay. Then next, looking at C, we have normal component. Okay, in this direction parallel to CB, that is 31.5 means 3.1 centimeter. Again we have perpendicular component, that is for CB. So these two perpendicular component of AB and CB will define orientation of B. So we'll just cut that, we'll connect that part O dash B dash and B dash A dash. So this is the orientation of that point B. Okay. Then next we have to look at point D. D is in downward direction, we'll plot D in upward direction. So this is 10.67 means 1 centimeter. Again draw one perpendicular line. Again draw one horizontal line from O dash to dash. So this is the orientation of D. So connect B dash and D dash, connect C dash and D dash. So this is all about orientation of D dash, that is slider D. So acceleration of CD will be this distance into scale, that is 1.1 centimeter into scale 10, 1:10. That is our scale. So this value will be 11 meter per second square. And we need to ask tangential acceleration of BD. So tangential acceleration of BD will be Q dash D dash into scale. Okay, so this is Q dash D dash distance, that is 3.85 into 1038.5 meter per second square. Okay, so we can find out this acceleration value and tangential component and angular acceleration of acceleration for this case. Okay, so this is all about values related to acceleration of standard D and angular acceleration of tangential acceleration of BD. Okay. So this angular acceleration of BD will be tangential component upon actual length, that is 38.5 upon 0.45. 0.54, that is 71.296. Okay, so this is the value of your final value of angular acceleration of BD. Okay, 71.29. Okay, so stop here. This is all about how to plot acceleration diagram for this arrangement.